All right, so we got the baseball problem in problem 13. Okay, so there's your deal. And we got to create an appropriate display. You're going to find out 95% confidence interval for the American League. And then we got to look at the National League. So we put the data in your calculator. All right, so L1 for me is the American League, L2 is the National League. So let's look at a histogram. All right, so that's a little skewed right, but it's roughly unimodal and symmetric. Okay, let's change that to L2. Okay, so that's definitely skewed right. So let's see what our window is. Let's see if we can fix that. So the minimum is, let's see if we can go up by 2s. So we'll go from, what's our largest number there? 14, and the smallest number is 7.9. So let's see if we go to 17 to 15 by 2s, what happens? Alright, well that's not as skewed. However, if I go to a modified box plot, you see that guy right there? That's that deal. There's definitely an outlier there. Alright, as opposed to if I do it for L1, the American League, I don't have that outlier. Alright, so there's an outlier in the National League. It's that 14. The American League doesn't have it. So I got to just go and get there's my statistics for the American League. Okay. So, okay. So again, we would go through, and P U of America is the average or mean number of runs scored. An American League game. Alright, and then A, assumptions and conditions. Well, this represents the 2001 sample, so this is a representative sample. Each park is independent where the games are played. Our N is 14, so 14 is less than 10% of all average runs scored. And we already looked at the histogram, so we would draw that histogram, whatever that looks like. So you get something that looks like that. So that's unimodal and symmetric. So that's good. So name it. This is a 1 sample T interval. Our statistics, X bar is 9.8. Standard deviation is 0.805. And N is 14. Okay. The interval itself is going to be 9.8. In this case, we got a T with 13 degrees of freedom for 95% confidence interval. So we're going to do inverse T of 0.975 with 13 degrees of freedom. And that is going to be plus or minus 2.16 times S, 0.805 over the square root of 14. And then we're just going to go to the calculator and let the calculator calculate it. We're going to go to T interval. There it is. Okay, so we're just going to calculate it from L1. And there it is. So 9.3 to 10.3. So our conclusion then is we are 95% confident the average number of runs scored in the American League is between 9.3 and 10.3 runs per game. Again, that's an average, okay? Then we go to C. What's the problem with doing the National League? Well, the problem with doing the National League is, again, this if we bring up that modified box plot, we got an outlier. So when we have an outlier, we have a problem. We can't just throw it out because we don't have a rationale for throwing it out. So the problem is we can't just do it if we have an outlier, or we'd have to proceed with caution. So the question D says, well, what's the problem with Coors Field? Well, if you look at how far it is away, let's zoom in or trace it. Let's see, the IQR here is about 2, right? 10.25 to 8.35. So it goes from 11.6 to 14. So it's almost two IQRs above the other maximum. So it's definitely pretty far out there. It's not like it's just slightly off. So that's the issue with that. So then it says, explain why you should not use two separate confidence intervals to decide whether the leagues differ. The problem is, if you use two separate confidence intervals, you don't do this. You know what this is? Standard deviation of 1 squared over n sub 1 plus standard deviation of 2 squared over n sub 2. In other words, if you just take this confidence interval, get a confidence interval for the National League and just subtract them, why can't you just do that? The problem is this: you don't add the variances. Now, when you're looking at the difference between two means, you have to add the variances. So you can't just take two intervals, independent intervals, and just combine them or just subtract them. Okay, because you're not, statistically it's not sound because you're not adding the variances.